I assume you're in a location where you can interact with your environment. At least I hope so. Creating new experiences with your senses. You can see all sort of light, feel the temperature in the room, smell and taste the food that you're eating or preparing right now, and perhaps you can hear the doorbell. You're witnessing these experiences from your own perspective, regardless if you're alone or not. You're the only one who can describe it the way you experienced it. But human nature makes it so that we share our experiences with others. But what's the best way to share experiences? That's communication, of course, or memes. Like it or hate it, still a form of communication. And the best method of communication is language. Well, for humans at least. Hello and welcome to a new episode of Cosmic Thoughts. You're watching The Cosmic Student, and in this video, I want to talk about mathematics. What, you thought I was going to talk about language? Silly you. But yes, I'll talk language too. The purpose of this video is to share what I've learned about math, the language of the universe. I have to be very careful how I use the word math because, my accent actually make it sound like I'm saying something else. But I digress. Math is universally considered as being the language of the universe. Numerals, which are the symbols used for numbers, is how humans read and write quantities or amount in a nutshell. Specifically with the Arabic numeral system that we are all familiar with. Like if a hypothetical alien species sees the number 3, they won't have an idea what is it. But wait, if they wouldn't understand numbers, what makes mathematics the language of the universe then? To answer that, we need to establish a few things first. To begin, what is math? My personal understanding of math simply being a human system to calculate or compute abstract ideas like equations and concrete things like quantities, shapes, and sizes in a logical manner for humans to describe the world we live in. I hope it makes sense, but if it doesn't, fear not. Here's a definition by the Britannica Dictionary with a more detailed definition. Mathematics, the science of structure, order, and relation that has evolved from elemental practices of counting, measuring, and describing the shapes of objects. It deals with logical reasoning and quantitative calculation, and its development has involved an increasing degree of idealization and abstraction of its subject matter. Since the 17th century, mathematics has been indispensable adjunct to the physical sciences and technology, and in more recent times, it has assumed a similar role in the quantitative aspects of the life sciences. So what's math origin? Math started simply with counting. We can trace back the origins of mathematics to about 18,000 BC via the Ishango bone, discovered in the namesake town of Ishango in the Democratic Republic of Congo by fishermen. We can easily identify tally marks engraved in this primitive calculator. Due to its wear and tear, it's impossible to identify which animal the Ishango bone belonged to. Fun fact, counting isn't only used by humans. Animals count too. Actually, I didn't know that. This is something I just learned. Back to the history of mathematics, right? In more recent time, new innovations were then created. The first equation by the Egyptians, Greek invention of geometry and numerology, negative numbers invented in China, the number 0 first used in India. Persians wrote the first book of algebra, the boom of math in the Renaissance with the sciences. Da Vinci was going crazy, you hear me? And I want to personally add mathematics in arts with the projective geometry as the concept of perspective, a popular technique used in paintings. Mathematics can be separated in two branches. The first, pure math or abstracts, which explores the abstract concept and complex patterns that shape our reality. 1 plus 1 equals 2. Adding the imaginary symbol 1 2 times to come up with the imaginary symbol 2. In practice, we use this abstract rule to measure quantities. 1 orange plus 1 orange equals 2 oranges, or 1 orange plus 1 apple equals 2 fruits. Fruits are objects you can interact with in the real world. Numbers are abstract objects. In the second branch, applied mathematics, or concrete or practical, which provides solutions to real-world problems. An article in the comap.com, I'll leave the link in the description, states that applied math is the bridge between mathematical theory and practical application. It involves taking established mathematical concepts and applying them to solve tangible problems in fields like engineering, physics, healthcare, environmental studies, public policy, economics, and finance. The goal is not just to explore mathematical concepts for their own sake, but to use these principles as tools to make sense of the world around us and improve various aspects of human life. The way I picture it, engineers they calculate the dimension and the weight capacity of a bridge. Astronomers calculated the gravity to slingshot Voyager 1 around Jupiter. Computer scientists creating machine learning and AI using equations. It could be as simple as a cashier calculating how much change to give you back, or as complex as a rocket scientist calculating the trajectory of a rocket to be launched into space. These are all real-life practical scenarios where mathematics is applied. I, as a kid, wasn't good at mathematics. I'm not. But the older and wiser I get, I understand math and learn to like it more. Specifically, how it's a fundamental skill to have in science and technology. Fields that I am a fan of. Here's how Mathnasium explains the usage of math in sciences. I'll leave a link in the description. Mathematics is the language of science and technology, from physics and chemistry to computer science and engineering. Math is an essential tool for understanding the world around us and developing innovative technologies. For example, in the field of physics, math is used to describe and model the behavior of matter and energy. In chemistry, math is used to analyze chemical reactions and predict the properties of different substances. In computer science, math is used to develop algorithms and write code that powers our digital world. All subjects that contain math uses pure math at its basis, be it counting, adding, dividing, multiplying, subtracting, measuring distances, calculating angles or surface areas. The difference is that pure math uses abstract objects, while applied math uses real-life items and objects. But both apply the same method. It's like pure math interprets applied math, or applied math interprets pure math. I think that makes more sense. You know, like an interpreter, a language interpreter. I usually structure my videos by separating each topics in parts to maybe bring everything back together towards the end, right? And I dedicated this very part of the video to language. I can speak and write in 4 languages. That's not even counting the programming languages that I'm also fluent in. So I went in this with chest, thinking it was going to be easy work, light work. Then it hit me. Linguistics, the science which study languages, don't have a proper definition of what a language is. So, wish me luck for this next part, but you'll get the point. Language is a complex concept, which, until new archaeological evidence shows up, its origins will remain theoretical. It is also theorized that its origins started about 200,000 years ago. And the fact that it's been with us for so long makes studying its origin nearly impossible. Unlike fossils, which in itself is data, have various methods of analyzing and study. Language is one of those default factory settings humans have. But asking the origin of language is like asking when did humans started to be self-aware. Then what is language? Let's go there. Let's try to see if we can find something there. And as per my understanding, language is simply a form of human communication. We know that animals can communicate, like a bee buzzing or vibrating to alert others for food. I had a dog that when he was hungry, he used to take his empty bowl and just drop it in front of my feet. It's just to let us know, like, hey, look, listen, I'm hungry. Here's my bowl. Fill it up. And no joke, when I used to sleep, like take a nap on the couch and the bowl was empty, this dog will come on the couch and hit me with it in the head. No joke. With the bowl to make sure that he gets food. He knew how to get our attention. Interspecies communication at its best. All of those are examples of animals communicating. But do all animals have a structured language? Wikipedia defines language as being a structured system of communication that consists of grammar and vocabulary. It is the primary means by which humans convey meaning both in spoken and signed form. It may also be conveyed through writing. Human language is characterized by its cultural and historical diversity, with significant variations observed between cultures and across time. Human languages possess the properties of productivity and displacement, which enables the creation of an infinite number of sentences, and the ability to refer to objects, events, and ideas that are not immediately present in the discourse. It goes without saying, language have many rules, but most languages at their basis possess a vocabulary, which is the body of words used in a particular language. 2, they possess grammar, which are the rules of a language governing the sounds, words, sentences, and other elements, as well as their combination and interpretation. Third thing is syntax, the arrangement of words in sentences, clauses, and phrases, and the study of the formation of sentences and the relationship of their component parts. It isn't as simple as that, of course, especially if you go into the nuances of linguistics. Trust me, it becomes even more complicated. Language is not as simple as it seems, but this is pretty much the basis. And if a sentence have this sort of structure, communication between humans become easy. If someone decides to learn a new language, if they go with this basic basis of vocabulary, grammar, and syntax in the new language, they will grasp it very quick. Again, only linguistic nuances will make a difference. Things like phonetics, phonology, syntax, semantics, pragmatics, etc. can create specific regional meanings to communicate. These rules don't only apply to spoken languages. Written, sign, and programming languages, among others, can follow these rules. But in general, language is a form of communication consisting of objects following a specific rule arranged in a logical manner to share information. Vocabulary, grammar, and syntax in a nutshell. But if we're talking about words and grammar, how does this apply to mathematics? This part isn't from my own inspiration. All credits go to Accelerate Learning, TFSM.com. They did all the heavy lifting. In the article titled "Is Math a Language?" Exploring the relationship of language and math. I will link the blog article in the description, but without further ado, let's check it out. C.J. Thompson, the author of the article, had to say some baselines. For starter, asking the most obvious question: is math a language? This is what CJ had to say. In considering whether math is a language, we first need to ask, what exactly defines a language? And does math meet this criteria? One common way to define language is a system of communication that conveys ideas and concepts. Another way to think about language is by considering its components part. A language has vocabulary, the basic units of meaning, words or symbols, and grammar, the rules of using vocabulary. A language also has syntax, the structured order in which these symbols are arranged to convey meaning. These components work together to allow the communication of ideas. On careful consideration, most of us will agree that math fits this definition. So let's compare math and language components to visualize and help further the point. Here, CJ uses more practical examples in order to drive the point, right? Consider equations. They are kind of mathematical sentence, concisely expressing relationships and properties. Let's take the simple example, 2 plus 3 equals 5. We have a vocabulary including numbers 2, 3, 5, and symbols plus equals. We also have rules of syntax and grammar that dictate what is allowed and how the meaning can change with changes in syntax. Consider the following change to our example. 3 plus 2 equals 5. This equation or sentence is still grammatically correct, even if it has a slightly different meaning. Now let's try something else. 2 plus 5 equals 3. Although this version seems to follow the rules of syntax, it is not grammatically correct. This is precisely how language works. Let's try this with a simple English sentence, right? Red and green are colors. This sentence is syntactically and grammatically correct. We'll make a small change. This time, green and red are colors. This one is slightly different, but still correct. Now let's try this. Red and colors are green. Once again, although we are following the rules of syntax, the sentences do not convey a logical correct idea. So, is math a language or a science? It's another very good question. The ties between math, again, I'm still going on the CJ article. I'll leave the link in the description. The ties between math and science are numerous and strong. Math is often called the language of science, and with good reason. Math gives scientists a common framework for explaining, evaluating, and forecasting natural phenomena. In all scientific disciplines, including physics, chemistry, biology, etc. Mathematical concepts like functions, equations, and statistical models are indispensable resources. For example, Newton's law of motion are mathematically expressed in physics to predict how objects will move. Differential equations are used in population growth models in biology to comprehend ecological dynamics. Math acts as a universal language, bridging disciplinary boundaries to facilitate more profound discoveries and improved communication within the scientific community. Many of what we call laws in science are basically mathematical equations. Perhaps the most famous example of this is Newton's law of universal gravitation, the law that describes the force of gravity between any two objects in the universe. What might look complex at first is actually pretty simple. Mathematically, the equation is made up of some multiplication and divisions, allowing that squaring is just multiplying a number times itself. Looking at it as a sentence that describes gravitational attraction, What does it tell us? The force of attraction, or F, depends on equals the mass of the two objects we're looking at, M and M, big M and short m. The distance between them, R, and other number, the gravitational constant, G. Starting with that basic idea communicated through the language of math, we can derive other ideas and express them in simple language. If the mass of either object, big M or short m, gets bigger, the force of gravity, F, gets bigger. If the distance between the objects, R, gets bigger, the force of gravity, F, gets smaller. The connection between the math and the word is clear. Understanding one helps us understand the other. We're basically translating from one language to another. So, math, universal language. What is that about? Math is frequently referred to as the universal language, a tool that transcends linguistic and cultural barriers. Its basic concepts are universally applicable and offer a basis for mutual comprehension and communication. The meaning of the equation E equals mc squared remains the same whether we're in Houston or Hanoi. Because of this universality, math is a language we can use to communicate with others around the world. Should we encounter intelligent life beyond our solar system, math offers our best chance as a viable form of communicating with them. Here on this planet, in our classrooms, math as a universal language promises more tangible and immediate benefits. Students new to the country and struggling with English frequently do better in math class since, no matter where they come from, that part of the world still uses the concept of numbers, addition and subtractions, multiplications and division, etc. Students who struggle with verbal communication for other reasons also can often be reached through language of math. For the last part of this video, I was going to provide different hypothetical examples to show how we could use math to communicate with possible intelligent extraterrestrial life forms. I came across this article which details the work by Carl DeVito, a professor emeritus in the mathematics department at the University of Arizona in Tucson. In an interview with Space.com, Dr. DeVito explained, designing a signal that attracts attention and, on examination, is clearly the work of intelligence is a complex problem, DeVito told Space.com. And him being a good scientist, he didn't leave it at that. He had to put on some motion and find a solution, which he did in his book, Science, SETI, and Mathematics. SETI, if you remember from one of my past videos, means the search of extraterrestrial intelligence. Back to the book, DeVito spotlights the famous German mathematician Carl Gauss, who suggested in 1820 the planting of large swaths of Siberian forest in a graphical demonstration of the Pythagorean theorem. Some 20 years later, Austrian astronomer Joseph von Littrow was keen on touching of kerosene-filled trenches in the Sahara Desert that took on the form of various geometric shapes. Scientists thought that such large displays on Earth would surely grab the attention of faraway intelligent life. Doing so, they reasoned, will be communicating our planet's intellectual prowess. Neither idea was carried out. The article went on to indicate that DeVito had a different approach, an approach of perhaps identifying mutual interest between species. He suggests that for two societies to be able to exchange precise scientific information of mutual interest, they must first learn each other's units of measurements. Together with linguist R.T. Orle, DeVito has developed a language for exactly that purpose, potentially enabling civilizations from different star systems to report to each other the masses of their planets, the chemical composition of their atmospheres, or the energy output of their host star. DeVito admitted, for the language to work, for that new language to work, the following assumption needed to be made first. Because again, we're talking in a theoretical slash hypothetical scenario, right? So these assumptions are both societies, humans and the extraterrestrial life form, can count and do arithmetics. Both societies recognize the chemical elements and the periodic table. Both have made a quantitative study of the states of matter. Both know enough chemistry to carry out chemical calculations. Regarding these suppositions, all known to humans by the 19th century, the video said we can communicate the gram, the calorie, the degree in Kelvin, and our units of pressure. But potential difficulties of this approach were identified, of course. It's not going to be flawless. For one, an alien race might start with a different geometry and derive its laws of motion in that geometry, which the results might be very different from the formulation of the laws that are familiar to us. The video said, he continued, the mathematics of motion is differential calculus. Can we assume that an alien race shares this with us? Differential and integral calculus are so fundamental in so many areas of science that it is hard to imagine a science without them. But this is perhaps a human bias. We, of course, can't know, but we must be aware that the physics of an alien race, even in a fundamental area like mechanics, might differ in subtle but important ways from our own. So we have to be careful for that. So I mentioned earlier, math is made up of different abstract notions human invented. And although many of the laws of physics are pretty much laws of nature, the way we interpret in order to understand it is by using these abstract notions. Geometry and calculus help us calculate shapes and motion. It's our way of understanding it. Think of it as a tool that we know how to use. Even if an alien species that understands physics, they will only understand it with their own set of notions or tools. The video closed out the article by stating, given the alien understanding of physical reality, we must begin to construct a language to communicate with ET, whatever amount of mathematics is thought necessary. Though he acknowledged one of our human characteristics may make this task difficult. He said, we Earthlings certainly want to present ourselves as highly intelligent race. In putting our best face forward, we want to be seen as a life form that has achieved much and learned much, he said. But is wise enough to realize that there is much more to learn. If you made it this far and you are a regular viewer, I don't have much, so thank you for coming back. And I want to acknowledge that this video isn't about astronomy as usual. Instead, I focus on an important component of physics in mathematics. I wanted to really grasp this concept of math as a universal language for myself, and I hope you enjoyed. If you dig this video, please hit the like button and consider subscribing if you enjoy this type of content. And as always, I thank you very much for watching, and I'll see you on the next one. Take care.